IEEE 30 buses. Okay, here let us zoom out. This simulation created by PSCAD team or PSCAD center. Just I downloaded from PSCAD website, and just I did a little modification like inserting breaker, viewing some measurement in graphs, just a little modification. But the original file I downloaded from PSCAD center website. Okay, what we have here, bus 1 is slack bus and rated to power supply here rated to 132 kilovolt. Bus 2 also the generator here rated to 132 kilovolt and MVA base 100 MVA, and the voltage, these are base voltage 132, and here there is a voltage magnitude line to line RMS value 137 kilovolt, frequency 60 Hz. This is the phase. This is initial power and active power and initial reactive power. Okay. Other buses consist of just only synchronous generator. No, we don't need source control. Initial real power 0. Just only running as synchronous condenser to generate reactive power. Here also synchronous, and here synchronous. So we have 2 buses for generation and 3 synchronous condenser here. So this interconnected grid or network. So this transformer to step down from 132 to 33 kilovolt to 33. If you see here, this 2-winding transformer from 132 to 33 kilovolt. Step down transformer, star, earthed, neutral grounded, and tap changer to set tap changer setting 0.97 per unit. And for measurement, I can show, if you see here the measurement, I can show the measurement in per unit by entering base MVA 100 for MVA for power and 132 here for voltage. Also here the measurement in slack buses 100 MVA and here 100, also here 100 MVA. Okay, so this IEEE 30 buses example, before here it was synchronous condenser, but they changed it, this bus 11 to solar farm PV integration into this interconnected grid at 33 kilovolt site. So here all this area here 33 kilovolt. and here we have capacitor bank rated to 19 megabar. So let us discuss about solar farm. So here this solar farm created a model. This model not in master library of PSCAD. No, this is model created by PSCAD team. So if we double click on solar farm, I found here also two models. This model for P reference and P reference. Okay, this also model inside model. So this solar farm model, just I want to mention here number of this unit about 100, and each unit rated to 250 kilowatt or 0.25 megawatt. That means the all generation from BV about 25 megawatt. If we double click in solar farm, here this is the BV array, and this BV array condition for irradiation and temperature 1000 for irradiation and 28 centigrade for temperature. I think this ideal condition for BV array. Okay, for BV array in PSCAD, if we double click on it, so let us show how yes, this is the BV array. Let us show how this BV array, how I get this 250 kilowatt from this array. Right. If I double click in BV array parameters, I find the name BV array 1. Number of modules connected in series per array 35, and number of module string in parallel 130, and number of cell inside module 35 in series and 1 in parallel. What does that mean? Just like this. We have how many modules? All is 135. Okay, module 1, 35 module in series from 1 up to 35 in series, and I have 130 module in parallel. 130 module in parallel. That means the last module is 130 plus 35 in series. That means the last module is 135. Okay, each module consists of 35 cells. Each module consists of 35 cells in series, and 1 in parallel. That means no parallel. 35 module in series. This for configuration of BV array in PSCAD. And here I have BV cell parameters. I have effective area in meter square. So this parameter or this effective area of cell give me each cell give me about 52.9 watt and only 0.8 volt. All right, so That means I have all about 135 all module, 135 module, and each module contain about 35 cells, and each cells give me only 52. That means 52 times 35, each module give me 1.85 kilowatt. This 1.85, and I have all 135. That means 135 times 1.85 kilowatt. That gives me all about 250 kilowatt. This for power. For voltage, I have 35 cells. That means give me 28 volt. That means each module give me 28 volt because they are connected in series. And I have in array, I have 35 module. That means 35 times 28. That means 1000 volt DC. This about how PV array. Then I have, because here I'm using maximum power tracking MPPT, we have boost converter to controlling DC voltage. Then we have voltage source converter, inverter, IGBT, to convert or to invert DC into AC. Then we have filter, LCL filter for harmonic filtration with damper. Finally, we have a step-up transformer from 1 kilovolt to 33 kilovolt. Here, not written in number, but by signals or by medium voltage base, MV base, and inverter base. For inverter base, VB base is 33 kilovolt, and inverter base is 1000 or 1 kilovolt. Okay, as I mentioned, and this connection is star, earthed, and primary is delta. So this is scaling because I have 100 unit of PV array with inverter, with voltage source converter I have, and this filter I have 100 unit. So that means scaling here by 100. This is scaling in PSCAD. And also I need for scaling V base and S base. System frequency 60 Hz. So this is about power circuit. For control circuit, I found here is imported signal from main page to this module, and here per unit base calculation. Just here is base divided by voltage for to get current base voltage. The is base divided by voltage to get current base. Here is a filter calculation. So I think also the method for controlling is BQ method. That means for BQ method we need to DQ transformation, so, and also need is here, is here for DQ transformation. First we need to use phase lock loop to get in theta, angle for tracking grid voltage, and then we use ABC to DQ form using theta. This is for voltage and here for current, and here's a PI controller for controlling VD and VQ, and I think big control system. And lastly here we convert again from DQ to ABC form. Then we get here the pulses, the firing pulses for IGBT for 6 GBT, and also we have optional BF mode, power factor mode, here for boost converter controller using MPPT, and here we have selector if using MPPT or not. Also I think there is okay, I think it's all about controller for inverter, on grid inverter. Here from this model only I get B reference here about 25 megawatt, and V reference, yes, only, yes, there is voltage right through detection. I think this powerful control for solar farm. And here you can select for BI controller gain and yes KB and TI, gain for proportional and time for integral. This is inverter control parameters, and I think this value based on best practice. Okay, let us run simulation. This is all about, all right. The runtime for simulation about 3 seconds, and the solution time step very small, 5 microseconds, only 5 microseconds. Now PV breaker on and PV 25 megawatt B reference we need it from PV, and no need for 0 megavar, that means power factor unity, only active power. Now PV come, PV active power increase. I think about 2 seconds all the 25 megawatt will get it from PV. And here for this measurement based in VA1, that means we show the value in megawatt and in megavar, but for voltage, because I entered base voltage 33, so I get it in per unit. I will get in per unit. Now almost 12 megawatt, and here this value in per unit. This value in per unit. Simulation time very slow, 5 microsecond. For monitoring bus voltage, here in VO bus monitoring, to monitor bus voltage 32.6, here 132 kilovolt. Now 0.7 second. Simulation running time up to now 0.78 or 0.8 second. So the voltage is 33. If we don't enter V base, that means 1 kilovolt base voltage, that means, but I have to run simulation from start to show in kilovolt. Now almost PV generate active power. Now 1 second, 21 megawatt, 21. And yeah, I want to show you the scaling. You see here the power 0.22 megawatt, and here power is 22 megawatt. That means scaling by 100. That means I have 100 unit like this. Now 22 megawatt, no reactive power. Next case is I want to change the radiation, and also I want to stop, I'm not to use MBBT, and I will want to see the contribution of MBT, but I think in next video. Now almost done. 1.3 second, 23 or so the maximum power you get it from PV about 25 megawatt. And if we see the graph, almost 25 megawatt, no megavar is red, and this is voltage. And also you can see the DC voltage about 1000 volt. Where is the graph? Here you can see 1 kilovolt, 1 kilovolt. This is a DC voltage. From per unit power. Point 0.25, each unit generate 0.25 megawatt. Now 24.45, 1.5 second. That means in 1.5 second I get all the generated power by this from this solar farm. We'll do some other cases in next video. Now almost 25 in less than 2 seconds. In less than 2 seconds. Also, I want to know the contribution of this 25 megawatt on other buses like slack bus. So this power should be decreased, and here also, because of this distributed generation, the voltage on all buses is okay for rated 32.2, 32. Also you can now this capacitor bank is off. Okay, now is about 62% for complete. Now we stop at 24.7. That means the maximum power is about 25 megawatt. The simulation time is 3 seconds, and now about 2 seconds. So this is the maximum power, 24.72. So this is all about the solar farm integration in this interconnected grid contain of 30 buses. In next video we see the influence of MBBT tracking. Now we are using MBBT tracking